Imagine we want to work out the area of a long rectangular room, split into two parts. The first part is longer and measures 5 units by 10 units, and the second part measures 5 units by 6 units. There are actually two different ways we can work out the area of this room. The first way is to work out the area of the red room by multiplying 5 and 10 to get 50 square units. The second way is to multiply 5 and 6, which would give us the area of the small room, which is 30 square units. If I were to try to express the working out that I've just done there, write an expression for it, it would look like this. I would say that the area, so first of all we worked out the longer room, so I'd say it's equal to 5 times 10, and then we'd have to add on the shorter part of the room as well to get the total area. So add 5 times 6, and then we would just evaluate each part in turn. So the whole area would be 80 square units. But then there's another way of working out the area of the whole room. The other way we can do this is just to recognize that the whole length of the entire room is going to be 10 plus 6. So instead, we could say that the area is equal to 5 times 10 plus 6. But because of BIDMAS, if we were to just evaluate this now, we would have to do the multiplication before the addition. So we'd have to work out 5 times 10, which is 50, and then add 6 to it, which is 56. But the area is supposed to be 80. So something's gone wrong here. To overcome this problem, we use brackets. If we put brackets round the 10 plus 6, then according to BIDMAS we have to work that out first. So now 10 plus 6 is 16, and 5 times 16 is 80. Now the fact that the area in this example is 80 square units is completely unimportant. What is really important are these two expressions in the middle. Because working things out in this way produced the same result each time, even though I did it in two completely different ways. And this will always be true. So that means we could actually write this out slightly differently. I could say that 5 times by 10 plus 6 is actually completely identical to 5 times 10 add 5 times 6. That means that this expression on the left is exactly the same thing as this expression on the right, just written in a different way. That result is considered so important, that fact, the fact that these two expressions are actually the same thing, is considered so important that it's given a name. It's called the distributive property. Let's take a look at what that looks like if we have an unknown in our expression. So this time we can't work out the area of this shape because we don't know that length there. But we can still express the area mathematically. We can build an expression that represents the area of this shape. To begin with, the area of the red part of the room would be 5 times by x, while the blue part of the room would be 5 times 6, which we know is 30 square units. So the area of the room is either 5 times x add 5 times 6, or the area is 5 multiplied by the whole long length of the entire room, which is x plus 6. That's how we express this length. We don't know how long it is, but we can express it as x plus 6. Now that's as far as we can go with this. We can't work out the area of the room. It's either 5x plus 30 or it's 5 times by x plus 6. That's the best we can do. But there is one thing we can do. We can also say that 5x plus 6 must be the same thing as 5x plus 30. These expressions, this one on the left and this one on the right, they represent the same number, the same value, the same quantity. They just look different. They're written in a different form. And we know this thanks to the distributive property.